chemical equilibrium, acids bases lesson. Acids and bases. ఈ పేపర్లో what is the acid, what is the base, Arrhenius యాసిడ్ బేస్ కాన్సెప్ట్ అనేది ఉంది. ఈ లెసన్లో యాసిడ్ అంటే డెఫినేషన్ ఉంది, బేస్ అంటే డెఫినేషన్ ఉంది, యాసిడ్ సబ్స్టెన్సెస్ క్లాసిఫైడ్ యాసిడ్ బేసెస్ సాల్ట్స్ అని ఉంది, అరీనియస్ యాసిడ్ బేస్ కాన్సెప్ట్, యాసిడ్ అంటే అరీనియస్ ప్రకారం డెఫినేషన్ తర్వాత ఎగ్జాంపుల్ ఇచ్చింది. ఇక్కడ ఏవైతే జలద్రావణంలో H+ అయాన్లు ఇస్తాయో వాటిని యాసిడ్స్ అని, ఏవైతే జలద్రావణంలో OH- అయాన్లు ఇస్తాయో బేస్ అని ఇక్కడ ఎగ్జాంపుల్ తోటి ఉన్నాయి. లిమిటేషన్స్ ఆఫ్ అరీనియస్ థియరీ ఉంది. నెక్స్ట్ థియరీ లౌరీ బ్రౌన్స్టెడ్ థియరీ ఆర్ ప్రోటాన్ థియరీ. What is the acid? According to Lowry Bronsted theory, acids proton donors are called acids. Proton H+ acceptor is called base. సో ఇక్కడ NH3H2O తోటి ఉన్నటువంటి చూసినాం. ఇక్కడ కాంజుగేట్ యాసిడ్ కాంజుగేట్ బేస్ అనే కాన్సెప్ట్ వచ్చింది. 1 ప్రోటాన్ తేడా తోటి ఏర్పడ్డదే కాంజుగేట్ యాసిడ్ ఆర్ బేస్. Conjugate acid base. The acid and base pair that differ only by the proton is called conjugate acid base pair. According to this theory, every acids and bases formed their conjugated acid base pair. Bronsted is strong acid, then its conjugate base is very weak. Weak acid, then its conjugate base is strong. Conjugate acid has one extra proton than given species. Conjugated base has one proton less than given species. HClO4. What conjugated base less than one proton. So important concept. Star mark given. ఒక ప్రోటాన్ తక్కువ ఉంటే కాంజుగేటెడ్ బేస్ అవుతుంది, ప్రోటాన్ ఎక్కువ ఉంటే కాంజుగేటెడ్ యాసిడ్ అవుతుంది. ఆ పాయింట్ మీద గుర్తుపెట్టుకోవాలి. నెక్స్ట్ హైడ్రోక్లోరిక్ యాసిడ్, ఎస్టిక్ యాసిడ్, బేస్ హియర్ గివెన్. కాంజుగేట్ యాసిడ్ రాయాలంటే మనం ప్రోటాన్ ఎక్స్ట్రా చేయాలి. ఇక్కడ స్పేస్ ఇచ్చిండు, కాంజుగేటెడ్ ఇచ్చిండు H2O. కాంజుగేటెడ్ యాసిడ్ ఒక ప్రోటాన్ తేయాలి, కాంజుగేటెడ్ బేస్ అంటే ఒక ప్రోటాన్ తీసేయాలి. Limitations of Lowry-Bronsted theory. This theory is very useful only when the proton donor and proton acceptors are available together. It cannot be explained about the acid character of electron deficiency compounds like BCl3, BF3, LCl3. Lewis theory of acid bases. Lewis acid. The electron pair acceptor called acid substance which are accept an electron pair to form a coordination bond with the donor is called Lewis acid. Lewis base. The electron pair donor is called Lewis base, a substance which can donate an electron pair to form coordination bond with the acceptor is called Lewis base. BCl3 boron trichloride treating with the ammonia to form the BCl3 and NH3. Types of Lewis acid. All cations like Ag+, Cu+, Fe+, Co+, etc. The molecules which the central atom completed possessing vacant orbitals like BCl3, BF3, LCl3, FeCl3. The compound in which the central atom has available d orbital. Silicon tetrafluoride, stannous chloride, SF4, Ta4. 5 bonds between the different atoms in Lewis acids like SO2, CO2, SO3, NO2. Then elements with an electron sextant, sulfur, oxygen. Types of Lewis bases. All anions like Cl-, OH-, Cn-, NH2-, F-, SCN. The molecule with the one more lone pair electrons present in the central atom H2O, ROH, ROR, NH3. Pi bonds between the same atom acetylene, ethylene, benzene. So these are called bases according to Lewis acid base theory. The ionization constant of H2O and its ionic product Kw at 25 degrees centigrade, the product of the concentration H plus or and OH ions in the water is called ionic product. At 25 degrees centigrade, the ionic product equal to Kw equal to concentration of H plus and concentration of OH minus. At 25 degrees centigrade, the ionic product 1 into 10 to the power minus 14 mole square liter square. Acidic solutions, basic solutions. pH value, the negative value of logarithm of H plus ions molar concentration in a solution is called pH of the solution. pH equal to negative logarithm of H plus ions concentration. Significance when dealing with the same some biological cosmetics applications. Determination of pH the solution is very essential. P power of Ka equal to pH plus pOH is very important quantity of aqueous solution. pH scale is 0 to 14 range. So 0 to 6 is acidic, 7 is the neutral and bases. pH less than 7 acid, pH greater than 7 bases, pH equal to 7 neutral. pH plus pOH equal to 14. pH equal to 14 minus pOH. Log A plus log B equal to log AB. Log A by B is equal to log A minus log B. Log A to the power of M equal to M log A. Log 1 equal to 0. Log 2 equal to 0.3010. Log 3 equal to 0.4771. Log 4 equal to 0.6020. Log 5 equal to 0.6990. Log 10 equal to 1. So first problem, calculate the pH of 0.1 normal HCl solution. pH equal to minus logarithm of H plus and concentration. H plus ions equal to 0.1 normal. pH equal to minus log 0.1. pH equal to minus log 0.1 ని 10 to the power of minus 1 రాసుకోవచ్చు. సో log a to the power of m ఫార్ములా అప్లికేషన్ చేస్తే -1 ముందరకు వస్తుంది, మైనస్ ఇంటూ మైనస్ ప్లస్ అయితే log 10 ఈక్వల్ టు 1, pH ఈక్వల్ టు 1, highly concentration of acid. Calculate the pH of 0.01 normal HCl solution. Similar model, just you have to see 2 into that is the 2 came, this is the answer. Here same similar model, but concentration is the 0.001 normal HCl solution, the value came 3. Calculate the pH of 10 to the power of minus 1, 10 to the power of minus 2, 10 to the power of minus 3 normal HCl solution. Similar manner, H plus and concentration in normal 10 to the power of minus 1. So pH equal to 1. 10 to the power of 2 equal to 2. 10 to the power of 3 equal to, that is the pH equal to 3. Calculate the pH of 10 to the power of minus 3 molar H2SO per solution. So normality equal to this type of compounds. First of all, you have to change the molarity. Concentration must be in the normality. That purpose you have to change the H plus and concentration. In the case of H2SO4, so here H plus and concentration equal to molarity into basicity. Basicity nothing but total how many number of H2 ions here, 2. So molarity 10 to the power of minus 2, 2. So H plus and normal 2 into 10 to the power of minus 3. pH equal to log formula. pH equal to minus log 2 into 10 to the power of minus 3. Log A plus B formula. Log A into B formula. Log A plus log B. So solution, final solution ikkada pH equal to 2.6990. Calculate the pH of 0.01 molar of NaOH. సో మొలారిటీ నార్మాలిటీ సేమ్ కాబట్టి దీన్ని డైరెక్ట్ తీసుకోవచ్చు. సో హియర్ సేమ్ కాన్సన్ట్రేషన్ 24 - 2 pOH given already, that is the base కాబట్టి pOH వస్తుంది. దాన్ని pOH equal to వస్తుందంటే pH plus pOH equal to 14, pH equal to 14 minus pOH, 14 minus 2, so pH equal to 12. Calculate the pH of 0.005 molar barium hydroxide. సో here molarity into SDT చేయాలి, నార్మాలిటీలకు మారవాలంటే ఇంటూ OH మైనస్ అయాన్స్ 2 అవుతుంటాయి కాబట్టి దాన్ని ఇక్కడ pOH 2 వచ్చింది, pH కూడా 12 అవుతుంది. Calculate the pH of 0.05 molar in AOH solution. సేమ్ ఫార్ములా సేమ్ ఎట్లా వచ్చింది, లాగ్ A ఇంటూ B ఫార్ములా ప్రకారం ఇక్కడ తీసుకుంటూ పోయిండు. ఫైనల్ సొల్యూషన్ pOH equal to 1 పాయింట్ సంథింగ్ వస్తే pH equal to 12.6990 వచ్చింది. Calculate the pH value of NaOH in the preparation dissolving 0.3 grams of water to form 250 ml of solution. Normality equal to weight by GeW into 1000 by P in ml. Normality equal to 0.03 వచ్చిన దానికి మనము అప్పుడు దానికి pH వాల్యూ క్యాలిక్యులేట్ చేయాలి. సో ఈస్ ద గివెన్ ప్రొసీజర్, step by step you have to observe and understand. Next, solubility product. Write the solubility product expression from the following. Here given కొన్ని కాంపౌండ్స్ ఇచ్చిండు, వాటి యొక్క solubility product రాస్తున్నాం. KSP అంటారు solubility product. సో Ag2 సిల్వర్ క్రోమేట్ ఇచ్చిండు, వాటి యొక్క పాదాంకాలు అనేది పవర్గా అవుతున్నది గమనించాలి. జిర్కోనియం ఫాస్ఫేట్ ఇచ్చిండు, పవర్స్ ఇచ్చిండు. కామన్ అయాన్ అనేది common ion effect, the solubility of an electrolyte acid base salt in a water excess by the addition of another electrolyte acid or base or salt which has one ion, cation or anion common in the electrolyte. This is known as common ion effect. The ionization of acetic acid in a aqueous solution decreases by the addition of solution state. CH3CO ion act as a common ion and the shift to the equilibrium towards the left side. Acetic acid state and H plus N weak electrolyte. Sodium state strong electrolyte. As the concentration of the acetate ion decreases in the aqueous solution, ionization of acetic acid decreases. This is due to the common ion effect. The concentration of acetate ion in the decreases in the aqueous solution, ionization of acetic acid decreases. This is due to the common ion effect. Acetate ions is common. Common ion effect is an important phenomena in quantitative analysis. Common ion effect is principle is also used in the controlling of the H plus ion concentration in the buffer solutions. What is the salt hydrolysis? Explain the nature of aqueous solution of the following compounds: ammonium chloride, sodium acetate, ammonium acetate is there. The phenomena in which an ion, cation or both or salt react with the water produces excess of OH ions, H plus ions both in aqueous solution is known as salt hydrolysis. Ammonium chloride. Ammonium chloride is the salt of strong acid HCl and weak base ammonium hydroxide. It ionizes completely to form the ammonium and chloride ions. NH4 ions is the strong conjugated acid of weak base of NH3. Hence it reacts with the water producing the H plus ions. Therefore, the aqueous solution of ammonium chloride is acidic and pH is less than 7. This cationic hydrolysis. Sodium acetate is there. Sodium acetate is the salt of strong base NaOH and weak acid acetic acid. It ionizes completely into acetate and Na ions. Here CH3 is the strong conjugated base of the weak acid acetic acid. Hence, it reacts with the water producing the OH minus ion. Therefore, the aqueous solution sodium acetate is alkaline and pH is greater than. This is called anionic hydrolysis. Ammonium acetate is there. Ammonium acetate is a salt of weak acid and acetic acid and weak base ammonium hydroxide. It ionizes completely into the acetate and NH4 ions. CH3COO ions is the strong conjugated base, weak acid, acetic acid. And NH4 ions is the strong conjugated base of the weak base of NH3. NCH3CO minus NH4 ions interact with the water producing the OH and H plus ions respectively. So to form the H plus and OH minus water, that the anion cation is the salt undergo the hydrolysis. The aqueous solution is the ammonium state in the solution pH equal to 7. The water formation is takes place. This is the last one, buffer solutions. Now let us going to discussion of buffer solution. A solution of a solution which resists any changes its pH value and dilution or addition of small amount of strong acid or base is called buffer solution. Acidic buffer solution. Acidic buffer solution consists of a weak acid and the its salt with the strong base. Acetic acid and sodium acetate. It's prepared by the mixing of equimolar solutions of weak acid and its salts. Working an acidic buffer. Let us suppose the buffer solution is made up of acetic acid and the sodium acetate in which the few drops of strong acid like HCl is added. Then H plus ion from the HCl, a unit of acetate ion from the undissociated CH3H CH3COOH plus CH3COOH. Then affected the H plus ions nullified, so pH is does not changes. When the few drops of strong base NaOH is added, the OH minus form the base react with the acetic acid and the produce the undissociated water, acetic acid and CH3CO. Then it effects of OH ions is nullified, so pH does not change. Hence, the pH of solution does not change even the addition of small quantity of acid or base. The pH of acidic buffer can be calculated by the using Anderson equation. pH equal to P power K plus log concentration of salt by concentration of acid. Buffer solutions. Anderson equation.
Buffer solution is water tanky. Okay.